Hello guys, and welcome back to episode 7 of the Ethernaut challenge. So this one is titled Force. Some contracts will simply not take your money. Really? The goal of this level is to make the balance of the contract greater than 0. Why? Okay. Fallback method. Sometimes the best way to attack a contract with another contract, which means we'll need our readme and the help page above section beyond the console. The help page above. Use the remix IDE. Okay. Yeah. So let's get a new instance. And what is this? Okay, let's check the balance of this contract. Let's wait for the transaction to be completed, then we'll check the balance of this contract. Okay, this transaction has been successful. And if you check, oh no, I don't want to open that. If you check the balance of this contract, you can see it's 0, and we need to populate the balance. But according to the contract, let's see. Contract. According to the contract right here, there is no method. There's not even a fallback method, so we can't send ETA to this contract. So this brings us to the self-destruct method. Let's just still use this. The self-destruct method, I've done the video on that too, so you can check it out. It's a method where you forcefully delete a contract from the blockchain. So once you use the self-destruct method, it deletes the contract from the blockchain and sends ETA, whatever ETA that contract had, to the address you specify. So I'll create a function here. We call this kill, and we should take an address, the address we're trying to send ETA to. Let's call address. Let's call this end here, and we should make this public. And what else? What else should we do? Let's do this like this. Okay, then we'll call the self-destruct method and pass in the address. So once it deletes, what's happening? Even type of function call. Okay, this is address payable. My bad, I should just increase this. So once it kills this contract, it sends whatever ETA this contract has to this address specified here. So I will deploy this contract, because we are working on the rusting testnet. I'll go over to my deploy tab, and I'll switch over to the injected web3. This will connect to my MetaMask. As you can see down here is on rusting testnet, and we have some ETA here. So let's just make this constructor payable. So I will pass in some ETA on the stats. Okay, so we can deploy this contract. Let's give it one ETA, and we'll deploy this. And we can see the amounts here. Once we deploy this, wait for it to be completed. Let's keep waiting for the transaction to be completed. It's been completed here, and this is value. If we should check here, this should reload. Okay, I should just copy the contract here. Oh shit. And okay, so this is the address, this is the contract here. As you can see, the contract is visible. And what we have to do is call the key contract. This is the key contract. It takes the address of the contract we're trying to send our ETA to. Let's check the balance. Let's just check the balance of the contract we just created now, which is it. As you can see, we have one ETA. We have one ETA. Okay. And we can check the balance of the current contract. We have 0. So what happens when we kill this contract? I'll copy the instance. Is it instance, which is the address of this particular contract here, this first contract. So I'll copy the instance. And over here, I paste it in here. And then I kill this our contract. Let's see what happens. Okay, the transaction has been completed, it's mined. and you can see we've killed the project. Let's try doing this. As you can see, we can't get this again because this is out. The contract doesn't exist again. If we should reload this page, we can see a self-destruct here. The contract has been deleted. There's no detail about this contract anymore, so you can't choose this contract again. So if we should go back to Ethernaut and we try getting the balance of the contract we created, which is one we self-destructed, we can see 0. And if we try getting the balance of this particular contract, which is this first contract here, we should see 1. As you can see, we see 1. So we've done it. Let's submit this instance. As you can see, we've completed this level 2. So it is important not to count on this variable for any contract logic. If you're doing an accounting contract, never use value to dictate when to do stuff, because someone can still send you Ether and still hack your contract. We're done for this video, and in the next video, we'll talk about vault. I don't know what that is. We'll talk about vault, and hopefully I'll see you in the next video.